High-throughput acquisition of three-dimensional cellular objects can be performed using the MetaXpress Micro imaging system and the integrated MetaXpress software. In the following example, I will show you how to image a three-dimensional spheroid about 300 microns in diameter. We must obtain multiple images at different vertical z-planes in order to generate a 3D representation of the spheroid. The instrument will be set up to automatically acquire this stack of z-images. To begin, select a well that contains a stained spheroid. Under the Acquire tab, enable Acquire Z-Series. We will set up starting with the nuclear stain in wavelength 1, DAPI. To calculate your laser offset, click Use Z-Stack and then set a custom range that you estimate will cover the entire thickness of your sample in the well. Use a fairly large step size for this. For this spheroid, a 10 micron step size is suitable. Click Calculate Offset. You are able to see each image briefly as the instrument steps through the spheroid. Once the stack has been acquired, use the slider bar at the top of the window to approximate the thickness of your sample. You can adjust the contrast bar on the left side of the screen if you need to increase the brightness of your images. Move the slider bar to the right to find the top position of the stack and note this Z position. In this case, it is 9515. Next, locate the bottom Z-plane that first contains in-focus cells. 9315. Calculate the difference between the two to get a rough estimate of how deeply we can clearly image into this particular sample. Select the Z-plane image that is roughly in the middle of the object's calculated in focus range. In this case, that's about 100 microns above the bottom Z-plane. Click OK and override any existing settings. Repeat this for wavelength 2, but you don't need to recalculate the depth of the object. You may or may not get a Z offset different from wavelength 1. During acquisition, the instrument can collapse all the collected Z-planes into a single image for ease of analysis and to reduce the amount of computer storage space used. But if you want to perform 3D analysis on the object, you must save all the Z-plane images. Select the wavelength, and from the Z-Series drop-down menu, select Z-Series and 2D projection image. To choose which 2D projection is generated, select between Best Focus, Maximum, Minimum, and Sum. A projection is created at the time of acquisition, but by saving the Z-plane images, projections can also be generated from the stacks at a later time, if, for example, you find that a different 2D projection gives you better images for analysis. For this fluorescently stained spheroid, I chose Maximum projection. Repeat the selection for each wavelength. If I had acquired a bright field image, I would choose Best Focus for that stack. Advance to the tab Z-Series. We've chosen 11 planes, and I like to center Z-Series around focus result for a single spheroid in a well. If the 3D analysis you have planned involves measuring volumes, you will likely want to adjust your Z-plane acquisition to obtain more planes closer together for more accurate measurements. To build the best 3D image, collect planes until the images go out of focus. Click on the Run tab to begin acquisition of the entire plate. Notice that in the different planes, some cells are in focus while other areas are out of focus. The 2D projection image is seen last and is used to create the color overlay. As soon as the images are acquired, they are ready for analysis.